there are some mathematical sets that are commonly used, and they have letters are used to represent them. And they're so common that you can use an N and people will know you're talking about natural numbers. Or you can use the capital Z and people know you're talking about integers. So let's talk about these a little bit. So the natural numbers are the counting numbers. And it depends on your source. Sometimes 0 is considered a natural number, sometimes it's not. So in the textbook that we're using, it can include 0 as a natural number, but know that not all of them do. So these are really the counting numbers. So they're positive and they're whole numbers. And then there's all integers, and that includes also the negative ones. So it's 0 and all of the natural numbers plus all of the negative integers. And then now you can put a little subscript with a plus or a minus, and that indicates positive or negative. So Z plus is all of the positive integers, and Z minus would be all of the negative integers. Now notice 0 is not counted in this one because 0 is neither positive nor negative. So it wouldn't be included in Z plus or Z minus. Then there's Q, which represents all of the rational numbers. And that the rational numbers are real numbers that can be expressed as A divided by B. And real numbers are all possible decimal numbers. Now there's some picture ways to see this. So here we have the natural numbers and then the integers. And notice that the integers include all of the natural numbers plus the negative ones. And there you see it's represented with a Z. And then there's the rational numbers represented with a Q. And it includes all the natural numbers and the integers, plus these additional decimal numbers. And then there's real algebraic and real numbers include all of them. Now here's another way to look at it. And so here we see the whole thing are real numbers, and they're separated into two groups, the rational numbers and the irrational numbers. And in the rational numbers, there are integers, whole numbers, and natural numbers. Now here, this is the distinction where natural numbers do not include 0. So in this case, natural numbers would not include zeros. It'd be the counting numbers 1, 2, 3, 4, and up. Whole numbers would be all of those numbers plus 0. So whole numbers, all it adds is the 0. And then there's integer, which add all the negative whole numbers. And then rational numbers that include all the rational numbers, all the decimal numbers that are considered rational numbers. So some pictorial ways to represent these really basic mathematical sets. Now with this, we can use a different notation. So for all these sets that we've already talked about, what we're using here is roster notation. So we're saying here, we're going to list everything in the set. So we're just going to list every item, or we're going to list enough that we establish a pattern and then we identify that the pattern continues. So these are called roster notation. Well, there's another way that we can do it, and that's called set builder notation. And with set builder notation, you say, okay, this set equals, and now you still use the curly braces to identify what's in the set. But the way we're going to do it, we're going to say that X is an element, right? And so X is an element. And here we specify it's an element of the natural number. So here we're kind of identifying what group of numbers we're using. So we say X is an element of the natural numbers such that, so we're not, here, this could be any natural number, but now we're going to use the such that, and we're going to describe it in a way that it clarifies which one we are talking about. So here we could say, if we wanted to represent this one in set builder notation, we could say such that X is greater, X is greater than 0. Oh, I didn't get that right. There we go. Got it. So X is greater than 0 and X is less than or equal to 400. Now I need to come up with that special character that says less than or equal to. Let's see if I can find that in my mathematical special characters. There it is. All right, so it tells us the range, and x is evenly divisible by 4. All right, this is what set builder notation is. We say what general class of numbers it's an element of, and then we describe it so that we can say, oh, I know which ones are a member of that or not. That's set builder notation. Now we could do this with, this is commonly used with infinite sets. And so we could say, if this were an infinite set, we would say, oh, it doesn't have boundaries. It just is all values of x such that x is an element of the natural numbers and x is evenly divisible by 4. So that would be, what would that be if we did this in roster notation? If we did this one in roster notation, it would look like this. It wouldn't have the boundaries, right? So it's a natural number. It starts with 4 and goes up, so it's greater than 0, and it just keeps going. It's infinite and just keeps going. So these two match. One is the roster notation, one is the set builder notation. These two match. One is the roster notation, and one is the set builder notation.